Hello everyone. So let us solve the next type of problem, that is sinking of the beam. So analyze the continuous beam if B sinks by 12 mm. Okay, if the B sinks by 12 mm. So the value of E is given as 200 kilonewton per mm square, and I is equal to 20 into 10 to the power 6 mm raised to 4. Okay. Now see here, one value is in terms of kilonewton and the other is mm square. So you have to retain this kilonewton as it is and convert this mm square to mm square to meter square, and mm raised to 4 to meter raised to 4. Okay. So here the calculation is little clumsy. So I've made a detailed and neat calculation here. Okay. Now see here, in this, you can see. Okay. So value of E is 200 kilonewton per mm square, and I is 20 into 10 to the power 6 mm raised to 4. Okay, so first keep kilonewton as it is. So I've kept here when I multiply E and I, so it is 200 kilonewton. So it is divided by mm square. So divide by, so I'm converting to meter. So to meter is 10 to the power minus 3. So because there is square here, so it is square. So now the value of this becomes meter. So I've written here meter square. Next, into I. I is 20 into 10 to the power 6. Write it as it is. Then wherever this unit is there, there you replace it with meter square. Meter is to 4. That is 10 to the power minus 3. So gets converted to meter. Uh, Close the bracket, 4 raised to 4. Okay, so now again, once you write this, next is, see here, 200, write as it is. Keep this units along with this, then it is easy to understand. So so it is kilonewton divided by, multiply this. 3 2s are 6, so it is 10 to the power minus 6. So this is meter square. This is 20 into 10 to the power 6, and 4 3s are 12, so it is minus 12. So it is meter raised to 4. Okay, then go on multiplying. So again, this is 200 kilonewton as it is into 20 this. So this 6 comes, when it comes on top, it becomes minus, becomes plus. So it is 10 to the power plus 6. Okay, 10 to the power plus 6, and here also this is plus 6. Here also this, when it comes above, it becomes 10 to the power plus 6. Then this is minus 12. So 6 plus 6, 12. Plus 12 minus 12 will cancel out. And this is raised to 4, and this is square. So square and raised to 4. So this will cancel. So you're left with square. So 200 kilonewton into 20. Okay, everything cancels out here. So it is 200 kilonewton into 20. So it is 2 twos are 4, 4, 4. So 3 zeros. So 4000 kilonewton meter square. Okay, so now this is the value EI, which is 4000 kilonewton meter square. This will be using for further calculations. Okay, so let's come back to the problem now. All right, so here this is the given beam. So you can see here AB, BC, CD, and DE. Okay, so it sinks by 12 mm. So 12 divided by 1000. Okay, so it is 0.012 meter. Okay, and you can see here in AB, BC, CD, there are absolutely no external loads. You can see here, no external loads. Only there is sinking happening here. Okay, so there are absolutely no loads, so sinking is happening. So you have to consider only the change in the signs, that is the deflection load. So delta becomes 0.012 meter. So fixed end moments. So first AB. So again, in AB span, right side support is sinking. B is sinking. So right side support is sinking. So it is minus. So minus 6 EI delta by L square. So minus 6 EI, we have already calculated here. EI delta is 0.012 divided by L square, that is 4 square, minus 18. Okay, so it is minus 18. Here also it is. BA is also same. This is also minus 18. Then MFBC is plus 6 EI delta by L square. So again, substitute all the values here. Be careful with the length. And MFCD, there is no sinking only happening here. Only sinking is affected to AB and BC span when you should draw the deflected shape of the beam. So CD is 0. DC is also 0. DE also is 0. Okay, so for you all to understand, it's a quick note. LHS RHS, you can just write like this, to understand. Okay. So next joint. So here joint B, C, and D. So BA, BC, CB, CD, DC, DE. Okay, you have to write all this. So BA, BA. So this end support is fixed support. So BA is 4 EI by L. BC, again C is the intermediate support. So it is also 4 EI by L. So both are 4 EI by L. Next, CB, CB is 6, here it is, this again B is the end support, so it is 4 EI by L. CD, okay, now D is the simply support, so because DE is the simply support, so it becomes 3 EI by L, so 3 EI by L. Okay, next, okay, CD, CE, DC, okay, at support D, DC and DE. DC, again C is the intermediate support, so 4 EML. DE, again this is the end support, so it is 0. Hmm. Substitute all the values here. So it is, add both of this, it is 2.33. Add both of this, 2.08. Then this. Okay, so K by summation K. So K by summation K is this 1 divided by 2.33, 1.33 divided by 2.33. Okay, add all of this. So when you add this, it becomes 1. Similarly here also. Okay, okay. Then moment distribution table. Then same thing, joint A, B, C, and D. Okay, so in joint AB, AB, BA, BC, CB, CD, DC, DE. Okay, then go on writing here, whatever you got, 0.43, 0.57, the same. Okay, distribution factors. Okay, then fixed end moments. You already got the fixed end moments here, minus 18, plus 16, plus 16, 0 and 0. Okay, now next, as usual, we'll be treating this like a uh, simply support and a fixed support. Okay, so balancing, because there is no extra moment here, though this is a fixed free end here, but there are no load only acting, because no load acting, so directly you can start with balancing. So add of both of this, minus 18 plus 16, whatever answer you get. Okay, so it is minus now, minus 2, so that answer minus should make it as plus into 0.43, then again same answer into 0.57. Similarly here, 16 plus 0. Okay, so change the sign, so plus 16 becomes minus 16, so it is minus 16 into 0.64, minus 16 into uh, 0.36 right here. Okay, then A support is a fixed support here. You can see here A is a fixed support, so it gets transferred here, this portion. Here also it goes on transferring. Okay. Hmm. Okay, so as usual, go on transferring here. CD also it is transferred, though it is a simply support, because there to balance this DE moments it goes on transferring. So here also once you balance this, transfer half of the load, half of the load. Okay, so half of this is here, half of this is here, this and this. Next is balancing. Okay, again at this joint balance, so it is minus 5.12. Hmm. Then change the sign, so it becomes plus into 0.43 into 0.57. Again same thing here, 0.57. Okay, 0.57 at this portion, then multiply with 0.064, 0.36. Okay, you'll get this. Next, half of this get carried out here, half and half. Be careful with the sign also, it has to be carried forward with the sign. Next, balancing again here, so it is minus, change the sign, becomes plus. Hmm, into 0.43, then here same, plus 0.18 into 0.57. Next, here it is plus 1.46. Change this sign, it becomes minus 0.93. Again, multiply with this 0.36, so it is minus 0.53. Then again, carry over movement as usual. Carry over this. Then So 0.465. Okay, 0.46. Again, multiply this. So it is minus, change the sign, plus, plus. Multiply with the distribution factor, same thing. Here also it's plus, so change the sign, minus and minus. So again, carry over, carry over, carry over for all this. Then finally is the balancing here. So balancing here is minus becomes, this becomes plus. Hmm? So it is plus, so it is 0.006. So again, here it is minus sign, so it becomes plus 0.008. Here also the same thing. So you should do this until you get the at least the second number should be a, so it should after point, at least the second digit should have a number in it. Okay, only till the second digit, that's enough. Third digit is more or less good. Second digit, if you have this 0, so 0.08, second digit should have a single number. So that is the time where you have to stop. So once you balance, then stop it, then go on adding all of these. First column, second column, so this should be equal and opposite, equal and opposite, and here it is one value. So once you get this equal opposite, then whatever you've done is right. If you get this is like a check file, BABC CBCD, it's like a check. Mm. So once you get all of this, you can just write it here only. Easy for you to understand with the movements. Then finally is the bending moment diagram. So because there are no loads here, so you'll only get the end moments above the support. So at A, it is 16.33. At B, it is 14.66. At C, it is 6.57. And at D, it is actually at this point, D, it is 3.25. Then actually at E, that is ME, it has to be 0. This is wrong. You have to just eventually make it 0. Draw it like this. From D, it is 3.25. E, it should be 0. So this is the bending moment diagram. Okay, this is a simple problem because there are absolutely no loads acting here. There is only the sinking of this support, because now though there are no loads acting, but still the support sink. Now this is because of the, you can see here, I and 2I values. This is because of these values it sinks. Because of the self weight of the beam, there is a sinking of the support. Okay. All right. This is how the steps are all same. So you have to make adjustments only in the first step, fixed end moments. Next is same thing, distribution factor, joint, that is moment distribution table, and finally the bending moment diagram. Okay. All right. With this, we'll end the problem. So that's all for today. Thank you.